All right, here we go with video lesson notes for section 6.3 and 6.6. In the last video, we saw arithmetic sequences and series. And so today you're getting the other type of sequence and series, which is geometric. So remember that in an arithmetic pattern, you were always adding something to get the next term. In a geometric progression, you are always multiplying something to get the next term. So whatever it is that you are multiplying, we call the common ratio. Couple reminders, when it came to arithmetics, whatever it was that you were adding was called the common difference. And so if you ever weren't sure what it was that was being added, you could always subtract one backwards to figure out what the common difference was. So for example, if this were arithmetic, you would have done 15 minus 5 to figure out what the common difference was. Well, you use the same kind of a trick when it comes to geometric sequences. If you're ever trying to figure out what it is that's being multiplied, and obviously this one's easy to figure out. This one you're multiplying times 3 every time. But for some of the tougher ones, fractions, decimals, whatever, you can always work backwards by division. So if I take any term and divide it by the previous term, I can do that to figure out what my common ratio is if I'm not sure. So it's always an easy way to figure out the common ratio. So for the first one here, again, they're just going through a little explanation to help you understand where this geometric pattern formula comes from. So you can see the numbers in there. It just identifies that progression. You know, same with arithmetics, you could do any of this by hand. You don't need a formula, but it's really a matter of efficiency. If you were trying to find the 20th term in the sequence, you don't want to continue to multiply by 3 again and again and again until you get to the 20th term. It's a lot quicker, a lot more efficient if we do a formula. So for this case here, and if you look at the general formula for the geometric sequences, so you always have your first term, you got your common ratio to the n minus 1 power. And so that's the general layout. Just like with the arithmetics, you also have geometric formulas in your formula packet that you would get. So here's what that looks like. So these are the two that we're talking about right now. We have the general geometric pattern formula. You also have a formula for the sum of geometric sequences, which we would call series. So do keep in mind that when you're using this formula, make sure you stick with order of operations. You got to deal with the exponent before you multiply times the first term. So just the little things like that can cost you at times, so be careful on order of operations. So going back to this guy, just to make use of that formula for a couple examples. For this first one here, you can see that we have a first term of 6, so that would go in for u of 1. The common ratio, you can see, would be -4. And again, if I were to take any term and divide it by its previous term, I would get the common ratio. And so that's the easiest way to see that this would be -4 if you weren't sure. And then to the n minus 1 power. So in this case, if we were trying to find the 12th term, then we got 12 minus 1 for the exponent. And so here's the setup that we would be doing. And of course, you can do that in a calculator to figure out the 12th term. With geometrics, you do tend to get some extreme numbers because it's geometric growth. You're dealing with exponents. And so numbers can become very large or very small pretty quickly. So you do tend to get a little more extreme type of values when it comes to geometric sequences. Again, here's just another example. This would be a great one to try on your own. It's going to look just like number 1. So if you want to pause the video and give that one a try, that would be good. But again, here's your first term of 200. You can see the common ratio is 1/2. One thing to be careful on is you never think in terms of division. So you would never say that I am dividing by 2 to get the next term. You always have to look at it as multiplication. So instead of saying dividing by 2, you need to see it as I am multiplying by 1/2 to get the next term. And that's what would help you see the common ratio is 1/2. But the rest is plug and solve. So going down here, if you remember back for what we just did with the arithmetics, in cases like this, where you have 2 unknowns, it may take 2 equations to solve it. So in this case, I don't know the first term or the common ratio with what's given to me. So if I have 2 unknowns, I'm going to need 2 equations so I can solve a system of equations. So if we just start by plugging in what we do know. So here we go for the first bit of information. My second term that represents the n value right there, and the u of n value is 14. So again, like the arithmetics, you got to remember the connection between u of n and n. N represents a term number, and u of n represents the value of that term. So if this is the 10th term, then you would see a 10 for n, and then this would be the 10th term. That would be the value of the 10th term. And so same with this example right here, we have n equaling 2, and its value is 14. So 14 goes in for u of n. Because the exponent is n minus 1, on the first setup here, you're going to have 2 minus 1 as the power, so we can just see that as r to the first. Same with this one here, I got the 448, which is my u of n value, and that's when the n value is 7. So if we plug that into the general setup as well, so this should say 448, not sure where that 224 came from. That should be 448. Then we got our u of 1, we have the r, those are both unknowns, and then the exponent is n minus 1, so in this case 7 minus 1 gave us a power of 6. So if you look at these guys, when it comes to dealing with multiplication and exponents, you can't really solve a system of this with elimination. You got to use substitution. So for this case, we took the first setup that you see here, and we get u of 1 by itself by dividing r over to here. So if we can see u of 1 equaling 14 over r, and that's what you're seeing right here, then we can use a little substitution here to continue on. So since u of 1 is equal to 14 over r, we're going to replace that u of 1 with 14 over r. And that's what's going to give you the setup that you see here. We got a r to the 6th on top and an r to the 1st on bottom. So if I subtract those exponents, then I get this look here. Divide the 14 over, gives you this look. Take the 5th root of both sides, and we figure out that our common ratio is 2. And if you sub that back into one of the earlier formulas, then you can get your first term of 7. Now you would have all the information you need to answer the question that is being asked. And the question was to find the 9th term. So now I can plug in my first term, my common ratio, and my 9 minus 1 exponent to get that solution. For the geometric series, again, a series is anytime you are finding a sum. So anytime you take the sequence and add all the terms together, that creates a series. So again, with series, you want to think of sum. So for these, you saw on the formula page just a minute ago that you do have a formula for your S of n scenario. So again, this is anytime you're dealing with a series or a sum. You can see by the plus signs that we're dealing with a series. So these are not commas, instead they are plus signs, and that's how we know it's a series instead of a sequence. So just finding the sum. You saw on the last page that there are 2 formats for this formula. One of these, and they're both on your formula packet. One format looks like this. The other one looks like this. I tend to go with this one. This seems to help students deal better with the order of operations of solving when you do it in this format. So that's the one I would encourage you to use. So just to plug in a couple things, I'll only show you one idea, and I have a test hint for you on this. Some of the tougher IB questions that you will run into this year, they don't tell you the individual terms like this one does. They give you sums, and so they might tell you that S of 1 is 5. Well, think about that for a minute. If the sum of the first term is 5, well, then the first term would have to be 5 in order for that to be true. And then the next thing that you're going to run into is they're going to say that the sum of the first 2 terms is 20. So if the sum of the first 2 terms is 20 and my first term is 5, what would that make the second term of the sequence? So if I take the sum of the first 2 terms and subtract out the first term, I would be left with the second term of the sequence, which is 15. That's one of those little tricks that hopefully if you're watching this video, you'll pick up on that. That'll be a key hint to you later on down the road in order to help you find the second term. You need to know the second term and the first term in order to figure out the common ratio. So I can now see I have a common ratio of 3 based on that little scenario that I just pointed out. So a few basic examples here. If we just plug into the formula, you can see that the first term is 5, so that goes in for u of 1. We got a common ratio of 3, so that goes here and here. If I'm looking for the sum of the first 8 terms of the sequence, then we stick an 8 in there for n, and the rest is calculator. Do be careful. I would encourage you to try at least one of these examples in your calculator, especially when you start throwing in fractions like this one does. People just get these wrong because they put it wrong into the calculator. So make sure that you always show a clear setup. So even if you get the answer wrong, you're still going to get a bulk of the points for a correct setup. But I would try this in a calculator just to make sure that you're doing it right. Make sure you're coming out with correct answers on this. Last one that you see right here, again, they're leaving out a key piece of information here. So we know the first term and the fourth term. We got to figure out the sum of 6 terms. So before I can figure out the sum, I need a common ratio. So that's where this one begins, is figuring out what is the R value. So anytime you're looking for a specific, like an R value, typically you got to go back to the U of N formula to figure that one out. And so that's what you're seeing with the setup here. So I got a U of N value of 6655 when R is 4. So if I did 4 minus 1, I have an exponent of 3. So if you divide this over to the other side and then cube root, you get your common ratio. And now you'd have enough information to go through with your S of N formula to figure out the sum of the 6 terms.